Okay, here we go. Second equation. I got a fresh piece of paper. Don't think that you're looking at the wrong one. Okay, so now we're looking at the second equation here, right? Or I'm sorry, second graph. And now we want to write an equation for this. So I'm still thinking about how to get back home. This is a slightly different take on how to do this. Honestly, the only difference between these two graphs is they've just been ever so slightly moved to a different point. Other than that, these are both flipped functions and they're both quadratic. Okay, so I'm still thinking, how do I get back home? And I'm going to write my transformation function. If you remember from the first video, what we're thinking about is we're thinking about for my x's, it's not really affecting a flip. And part of that is because if I flip this in the X region, it's not really going to do anything different because it's symmetrical generally in the vertical direction, and any change that would happen can be taken care of with a movement. So we don't really think about flips this way because we can do that in an easier way. Okay, so how do I get back home from way up here? Well, in the X direction, I'm only moving to the left one. Okay, so all that means is that I'm doing X minus 1, right? Because I'm getting back home. Okay, here's the different way to do it. So we know that this is an upside down parabola. We know that it's been flipped. And so what we also know is that the y is going to be negative. So what I can do with this is I can think of this as a negative y. But what I'm going to do is I'm going to put that into like kind of mini parentheses, because if you remember up at that one, we were thinking of it flipping and it did affect the way that it moved up and down. Well, I don't want to think about that. I don't want to think about moving in that direction. So instead, I'm going to think about it a little differently. If I put that negative on the outside, now what I can do is I can think about how this moved just like I always do. So how do I get back home from this point? Well, I would go down 1, 2, 3, 4, 5, 6, 7. Okay, so I'd go down 7. So that's a minus 7. Okay, so now what I have is I have my transformation function. And you see this. Okay, so how do we interpret this? Well, this flips. Oops. Spelled it wrong, sorry. This flips, and then here, this moves it moves it down 7. Okay, and from this flipped function, that's exactly what happened. So now, this is gonna drive me nuts looking at that spelled wrong. There you go. So now, how do I manage this? Well, the next step is identical to what we did up above. So I'm going to plug that into my parent function. Here's a little trick. X is already over here, so you can write your parent function like this. It doesn't really matter. And it's kind of nice to write it this way because then you can go left, right? Up to you. Doesn't matter to me. Okay, so I'm going to plug in this for my x. X minus 1 squared equals. And I'm going to plug all that in for my y. Minus y minus 7. Now, what's the big difference? Well, there's a couple different things. Right now, what I can do is I can think about getting rid of this negative. It's really just a negative 1, and I can divide both sides by negative 1. And when I do that, I'm actually staying outside of the parentheses, so don't think that I'm changing things inside. But what I get is I get a negative x minus 1 squared equals y minus 7. Okay, now if I'm going to solve my equation for y, I'm going to add 7 to both sides. I can write that in 2 different ways, but I'm going to write it like this. X minus 1 squared plus 7 equals y. There's your one answer, and let's not forget the answer we got above right here when we plugged it in. Okay, and then this answer is that rearranged for y. Now, when we're thinking about the target, this is golden. Okay, this actually gets you a 3 because there's 2 transformations in it. The 4 is going to be something we'll be doing probably next class. This, while it's equivalent, you're still getting the 3 on the target. It's no additional, I guess, credit. What it's doing is it's allowing you to get some feedback on your algebraic manipulation without fear of, being docked points or something like that. So it's up to you if you take that extra step. Again, if you are someone who plans on doing 4 years, going to Trig Pre-Calc, going to AP Calculus, I encourage you to practice this. Ask me questions if you're struggling with it. And let's see what happens. Okay. Hope this helped. Thanks.